Welcome everyone to Robot Builders Night Virtual for Tuesday, the 10th of June, 2025. And we'll start with DPRG news, and then we've got a short queue, and then go to open mic. So RBNV, we've got lunch, robot power lunch on Sunday for anyone in the DFW area. Going to be at the Derbyshire, which is an English pub up in Frisco. They have English food like bangers and mash and fish and chips, as well as typical American fare like burgers and English ales and other beers. And so anyway, hopefully it'll be a good and enjoyable time. They do have a seating limit of about 12 to 14, so but we haven't had over 12 on the previous two robot power lunches, so hopefully we'll be okay. And with that, I'm going to jump into the queue. Mike.
Unfortunately, that's also Father's Day.
Yes, it is Father's Day. I'm sorry about that. We were constrained by Doug and Mark going out of town this week, and so I was wanting to try and fit it in, but I know there's some conflict there, so I hope it doesn't hurt too bad. Who was that saying that said it's Father's Day, unfortunately?
Dave Ackley.
Oh, okay. Does that mean that you will be unable to join us, Dave?
That's correct.
I'm sorry to hear that. Yeah. You do what you can. Yeah, Mike, so what have you been up to?
Okay, well, I'm just trying to get ready get something going for the Robo Columbus, and so I dusted off my outdoor crawler, and I put it, like you can sort of see it here. Let me get it closer. Yeah, so I took all that stuff off from last year. Oh, there it is, sort of. And hard to get it in the picture here. And so I got this huge build platform that fits inside of my cabin, for my Jeep. And so I'll be putting the electronics on there and the sensors. But right now I was just trying to I thought this would be simple to get the camera working with a cone detector. And so
looks a little sad. You need to, flip the USB cord so it's, not a frown but a smile,
Yeah. So I have the I was looking for a cone detection AI, and it seems like Oak. I'm using it with my Oak D Light camera, and there's an AI model called Cone Slayer. It sounds really cool. That's what I need to do: slay those cones. And so I'm trying to get it to work. The only thing I've tried it on my. I can't get it to work on a Pi yet. I just won't install properly. I'm just having, requirements like different software packages that have to be there for it to work right, and I just can't get it working. And I just got to spend more time. But I did get it. Huh?
What brand of what camera do you have?
Oak D, the light version.
Okay. I'm sorry for interrupting.
Pardon?
I said sorry for interrupting you. Thanks.
Yeah.
Okay.
And so, but I did get Cone Slayer to work on my Linux workstation, but I couldn't find a good way to show it directly demonstrate it directly on the workstation and to share it. So I'm going to start it on my workstation.
This is on the workstation with the Oak D light hooked up to it?
Yeah. And I'll point the camera at it.
All you can do, right?
Yeah, so you can see.
Yeah, it's picking out the cone.
Yeah, so it's picking up the target, and it's the depth sensor is here, and it's detecting the depth, and it says it's 1.2 meters away. And I did measure with a tape. For some reason, it stopped running after a while.
So are you using the stereoscopic mode of the Oak D light?
Pardon?
Are you using the stereoscopic mode of the Oak D light?
Oh, yes.
Okay, so
And it's getting about 25 frames per second, even outputting the video and everything. So on my robot, I won't be outputting video, so I should get a good frame rate out of it. And so the idea is to get this AI working on my Pi and working on the robot platform itself, and then testing it out. I thought it was going to be an easy thing, but it sure is driving me crazy.
Well, that's pretty cool. So what do you? I'm trying to understand. So Cone Slayer is an AI that recognizes cones, and
Right.
then you've also got the Oak D light running in depth image mode and stereoscopic depth camera mode. So
Right.
how do those two modes relate to each other?
I'm confused.
I think you said you showed us the depth camera working and looking at the cone and showing how far away the cone was, but it wasn't recognizing a cone.
It was
That's not-
recognizing the cone.
Right, that's not what it does. It
Yeah, so the
depth of
RGB camera says there's a cone there, and it gives a coordinate, and also the stereo stuff is measuring the depths and everything, and then somewhere in the Python code it says, okay, what's the depth at this coordinate, and it gave me the correct distance to the cone.
Oh, so the Cone Slayer is finding the cone in the color camera image,
Right.
and then you're validating that it's a good find, if you will, by looking at its depth. Or you're going to use
Yeah.
the depth.
I mean, it's basically says this is a cone, this is a good cone, and then what is the depth? How far away is it?
Oh, I see.
And I guess
So
you
you
can
know
put
how far
a
you
label
need to
on there,
drive.
like if it's too far or doesn't make sense. But
Right.
yeah, but you can get like how much is it? 90%, 80%, 50%, and put a threshold on it so it doesn't. Yeah, so it has all those controls on it. I just got to get the darn software to work reliably. So this is something new for me. It's see if I can bring that up. It's the GitLab.com/ which one was it? Oh, there it is. KST _ EDT. I guess I could be sharing, I guess, what I'm looking for. Let me share my screen.
So no documentation that says Cone Slayer works on a Raspberry Pi 5 with a certain OS and all that stuff. Huh? You have to go find out for yourself, I guess.
So you get what it's KST. What is it? EBT. What? It's asking me to sign in now. I don't understand this. Huh. I didn't have to do this before. Oh well, so I guess I'm not going to be presenting. So, because I was able to get in before. Maybe I just typed it in wrong. Let me see. GitLab. It's in like the GitLab repository instead of the GitHub. Oh, there it is. Oh, see if I can share this. Are you able to see my my KSU EVT screen?
It's just a Windows Explorer window.
Oh. Huh. What? Is
Still the Windows Explorer window.
huh? Strange. I thought I used to know how to share stuff. Okay, never mind. So, but it's a neat. It's basically. I mean, Cone Slayer was built by a university, and they used like 10,000 different cone images.
Oh wow!
And worked through it a lot. They tested it out and they said, "Oh, we got to add this and this," and so they worked on it really hard and got what they considered a pretty good Cone Slayer. So, and then we're trying to get it working. They're letting people use it, and so I'm hoping I can use this as my AI model for the cone detection.
Very.
Hey, Mike, do they give you access to the images?
I'm not sure. They probably do. I haven't been interested in that yet. I just wanted to get whatever they did running.
Yeah. Mhm.
If I have to improve it, then I'd have to improve it. But yeah.
Mhm. Yeah, I'm just curious. If they, if I could get hold of a 10,000 image database, I could run it through models that I already have, which would be, that probably would help them even more. I'm pretty happy with my own, but I don't have 10,000 images though.
Oh, okay.
Yeah. Plus, it'd be fun to look at their images and see what they collected, and decide if you agree with the particular image collection. So who has this? Where did you put the link in? There's chat to the.
Oh yeah. Let me find that out.
Now, did you talk to these people specifically, or did you just
No,
go?
I'm just online, just trying to use what they have.
Okay.
I was Googling it and I found a Cone Slayer driving school.
me see. This is the. Is that it? That looks like it. Let me put this link into the. Where is that thing? Chat. Yeah, so that's basically their overview. I think that's the right page.
Hmm.
So it's like basically, if I can get a working model, I'd just be happy. Okay.
I'd like to look at that a little later and try and understand it.
Yeah. So I figured, I just wanted to get it to work before I tried to understand it. I was trying to figure out, I was trying to understand how to integrate it into your computer. And they seem to have a ROS interface on it too. So,
Oh,
like the Cone Slayer has they showed how to, they had some information on how to integrate it into ROS and stuff. So it looked like it had a really it looks like it was promising.
yeah. I mean, the lots of pictures on their webpage.
Yeah, but just trying to get the ML, AI model running. I've never gone down that path before to do anything besides just running a demo program in a GUI or something in a demo. It's like, okay, how do I actually get this thing to work? So, I got my work cut out. That's all I got.
You got time.
it's going by fast.
Cool. Thanks, Mike. I have something that I was quite proud of in terms of an accomplishment, but not really anything to show, maybe other than maybe other than a web page. But I've showed Lino Robot 2 a few times in this forum, and I finally got a PR accepted into the upstream repo that makes it available on Jazzy, and that works in simulation and in Docker and with at least one hardware configuration. So I updated some of this documentation, and in the installation section, there's how you install it on a robot computer, and how you install in Gazebo. So Gazebo had broken as well. So it now runs in Gazebo, and I think I demoed that last week. And then as well, there's now a Docker configuration, so you can do a Docker build and then run it in either in simulation or in supposedly on real hardware. And I haven't actually checked out on real hardware in the Docker when it's running inside of Docker, but I have checked out on my Minibot to make sure that this set of ROS nodes in this project will talk to micro ROS running on a microcontroller on an ESP32 on a WaveShare general driver for robots board. So it drove my Minibot robot around. Yeah, that was if I feel like this is was a significant accomplishment. Because now it tells you how to launch it in Gazebo and how to launch it Gazebo inside the Docker container, and then how to drive the robot whether in simulation or on real hardware. So this is getting one step closer to it actually in some configurations does achieve the goal of being able to run the same hardware, the same robot, both in simulation and in hardware.
So, but you use this software stack for Robo Rama, right?
Correct.
Okay. Mhm.
Yeah, not as you're probably thinking, not all that successfully, but that's
worked.
not the fault of the stack. That was
Right.
that was the fault of my stuff that I layered on top of it.
Right. Need to get it to do something that you want it to do.
Right. But I did get it. I did change it. So you had for Roborama, you'd changed the nav2 parameters in such a way that you got it to use the rotation shim to rotate to point at the goal, and then from there the pure pursuit algorithm to drive to the goal and rotate to the final heading.
I abandoned that part of those things in nav2, and I used something called vector pursuit instead
really?
of pure pursuit. Yeah, because I abandoned that because it just wasn't working that great. And,
Okay.
and then I got this other one working better. The other one might have worked with parameter set right, but the other one started working, so okay, I'm taking it. I'm going.
So yeah, anyway, that's what I did. I put in the rotation shim controller and then the pure pursuit controller into the nav parameters.
Yeah, it's easy to change your models, so that's good.
Yeah, it is. Just some parameters, and then you see if it works and you try and figure out why if it didn't. But anyway, it was sort of interesting. It's kind of a worldwide project because we got Juan Miguel Gemino in Singapore. So I had a couple of teleconferences with him about organizing to get this PR accepted because he owns this repo, and then I've been working with Thomas Chu in Taiwan to because he provided a lot of add-ons, and I'm working on trying to merge his content, what he did that has value, into the upstream repo.
Mm-hmm.
So getting a PR release for Jazzy that did simulation and hardware and Docker was a bit of an exercise in coordination as well as technically understanding all the pieces of the stack and working with the owner to make changes according to how he wanted it to be.
Mm-hmm.
Anyway, that's all I had. It was nothing really to show. But
are you leveraging Docker to coordinate with the other developers so that you can share and?
I'm sorry, I didn't catch the.
Are you using Docker as a leveraging tool so that you can share different trial and errors with the other developers of Linux?
No, I really just got it going because it was in there already, but it didn't work. And so, and there were a number of things that didn't work on the latest Jazzy. And in the process of that, I discovered that the nav2 development team has been doing about monthly releases into Jazzy. And so Jazzy navigation has changed quite a lot since Jazzy came out a little over a year ago through the vehicle of these monthly releases where they backport the latest features from their development branch.
Yeah, I was still using Humble, and I'd keep looking on Nav2 information, and they would always have these neat features, but it's like, oh, that it's not for Humble, it's for Jazzy. So I'm kicking it up to the next level.
Time to switch to Jazzy, Mike.
Right.
Anyway, this has got pretty decent documentation for, if you just want to like, you can install it and just see if you can like get it to work. Anyway, such as it is. That's what I've been up to. Anyone else got anything, or we'll throw it open for open mic? Tom, you're on mute.
Mic on. I don't have anything on my robot, but I have some interesting information on several other robots that you may find interesting that came across my desk this past week. I have a little show and tell for that, if you like.
Yeah.
Okay, let me just share my screen here. Now, you should be able to see that.
Yep.
Okay. The first robot requires that we go to Antarctica. So here's a little map. And what this is showing is part of the route taken by a scientific expedition from March and April of this year, which was sponsored by the Canadian Navy. They sent one of their new offshore Arctic patrol vessels with 15 scientists on board from across Canada to go down and spend a month doing a very wide variety of scientific experimentation projects and a lot of politicking and all the usual things that major governments do when their Navy goes somewhere else. They also included a 3-person CBC news crew for the entire duration of the trip. So the reason this came to my attention is because last week the CBC started releasing the videos from this trip. And if you're at all interested in either in science or in the Antarctic, I would strongly recommend you have a look at these. There's a couple of hours worth that I've seen so far, and they're just fascinating to watch the duration of this trip and a lot of the science that was done on board and the several places they visited on the Antarctic, where there are already, of course, various base stations, permanent foundations. The ship that they took was this one. Canada now has about 6 of these, and there's 2 more in production that have just been are just being manufactured. These are about 320 feet long. They're very interesting mixed function boats intended to help Canada implement better ability to monitor and patrol what's happening in the Canadian Arctic. Very, very nice boats, relatively new, mostly a patrol and monitoring vessel. It's not much of a military vessel. It's got a little tiny 25 millimeter cannon on the front, and that's all. And it doesn't go very fast, but it's got this beautiful helicopter hangar on the back and a lot of space for a lot of additional functions. So it made it easy for them to take these 15 scientists aboard, along with all of the apparatus and equipment and things. Now, the particular piece of equipment that caught my attention was this one. This is an autonomous 2-meter long electric boat, which is operated by the University of New Brunswick's Ocean Research Group. And they took it down to the Antarctic to do ocean bottom mapping, because much of the ocean off the coast of Antarctic is not mapped. So they began to do a whole lot of detailed mapping there to supplement what already exists. So this little boat's almost 2 meters long. It can be operated under remote control and autonomously, because when you're running a grid pattern all day long, the last thing you want to do is be moving the little sticks on your remote control. So it's fully autonomous as well. That's a LiDAR on the front. There's a magnetic compass up here. That's a GPS, and there are a number of other sensors on board as well. That's a little bit closer look. These are screen grabs taken from the CBC videos. They have a much larger amount of coverage of this particular experiment, along with many others. So there's a little better close-up of this little autonomous boat. running around off the coast of the Antarctic. This is the view of the bottom. You can see it's got twin electric motors. This is the fancy sonar system they use to track the bottom. The boat weighs about 130 or 140 pounds. It's quite heavy. And here you can see one of the Navy crew carefully lowering it from the mothership, if you like, down into the water in order to spend the day doing some mapping exercises. This is a little bit more detail on the autonomous robotic boat itself. The university did not build this. It was given to them by a company in California who makes a variety of these things. This one is called the EcoBoat 160, and I believe this is the one that the university uses. You can Google this if you want to learn more about the boat itself. It's all electric. It has an 8-hour duration time during mapping exercises, which it does at about 3 kilometers an hour. So it's quite a lovely little autonomous boat if you should be inclined to extend your outdoor robotics capabilities to the water. This is quite the little boat. This is another look at the description of this same boat on the university's website on their ocean research web pages. A little bit of different summary and some additional pictures. Now this is at the University of New Brunswick, and by an interesting coincidence, the Canada-wide Science Fair, Canada's national science fair, also took place last week at the University of New Brunswick. Some of you may know that I have spent many, many years quite involved with science fairs at the regional and at the national and at the international level. So this is Canada's Canada-wide science fair. I always monitor what's happening here because the regional science fair that I have had a long experience with, even though haven't been involved in the last several years, I still like to monitor what happens. We run one of the largest and most successful regional science fairs in the country, so we're pretty proud of that. This Canadian science fair basically runs 2 streams of experimentation, of research. There's the discovery stream and the innovation stream. The discovery stream is essentially pure research. So kids who choose to do experimental work that becomes very advanced and produces a lot of very, very good research outcomes can enter their projects into the discovery stream. If you're an engineer or you're inclined to do applied science or something related to that, where you produce a product or a service afterwards, you're probably going to enter your project into the innovation stream. That's where all the engineering projects go. This young man basically lives one town over from me, and he won the top prize in the innovation stream. He is one of the kids that we sent to the Canada-wide Science Fair from our regional science fair. So he got the top prize in the fair for innovation. Our fair sent 18 kids altogether this year, and they did very, very well. So I'll tell you a little bit about 2 of them because they did robots. This young man's robot, he's in grade 9, incidentally. This is his robot. This is an autonomous underwater vehicle, which happens to propel itself just like a sea turtle. This is a screenshot or a picture from some of the project documentation which he provides, which is all in the public domain now, which illustrates his robot swimming an autonomous grid search pattern. If you look at his published material, there's a lot more information that describes more about his robot. I'm just going to give you a couple of highlights. There's some mechanical and electrical layout information. You can see the robot, which is this cylindrical tube in the center, has 4 fins, which it uses to propel itself, and servos to operate those. It has a ballast control system inside. It has a camera on the front. And let's go on to the more interesting parts for us. The core of his computing power is a Raspberry Pi 5 with a Halo artificial intelligence hat on top of it. He also uses a couple of Arduinos, primarily to interface to the servos and also to a pressure sensor. He's got lighting, he's got ultrasonic transducers, he's got an IMU, there's a GPS, there's a Pi camera plugged in. I'm not sure why there's a solar cell on it, but I thought that was interesting. I figured at some point It all comes out of the refrigerator. Right? It all goes on there. This is quite a fascinating little device. There he is at his project display in the fair after he's been identified as best project in innovation. That would have been right after the awards ceremony, probably for publicity pictures. Here he is talking a little bit about his robot with an interested participant, probably on public viewing day. As I said, grade 9, very, very capable kid and very approachable as well. Really interesting group of people. This is one of the 18 kids that we sent, many of whom won very prestigious honors. And then there was this robot. This gentleman, also from our fair, has this robot, it's fixed in place in this particular implementation. It doesn't have any wheels or anything to move around on the floor yet, but he has 2 very, very extensive arm assemblies with grippers, and he's got a camera and a tablet which he uses for interaction with people. He calls this CareBot. His intended objective is to produce a humanoid class robot that's capable of interacting with people who need care. I can see him taking this to further steps. He's also in grade 9, incidentally, so he's got lots of room for improvement here. A little bit more detail on the mechanics of his system. He's got 22 servos to control the arms. This is the display tablet to provide impressions of facial responses. There's a camera here as well. The computing system that runs it is a Jetson Orin NX. I'm not sure if there's 1 or 2. There's other information suggests there may be 2 of them, but he has at least 1. Now, he didn't write an enormous amount of software of his own, but he has provided some really impressive engineering approaches by implementing and combining a lot of existing systems to provide him with the capability that he needed to make this thing work. He's listed a little bit of it here and here. He has systems for speech to text. He has a large language model that he's running, which would be for interpretation of spoken input. Let's see what else he's got here. There's some packages which he describes later as what he used to implement the language learning, the training that he used in order to cause this robot to actually be able to perform selected tasks. I was quite interested in how he did that. This is something called an action chunking transformer. I'm not sure what the other stuff is. I am not familiar with the packages he's used, but he appears to have made good use of them. Here's another very high level look at his processing architecture. Inputs from camera and from voice input, processing them through what he calls a vision language model, which I think is another package that he used. And some functionality which implements actions based upon the interpretation of what comes in through text and video. So in terms of knowing what he actually did with this thing, I looked through his online material to find out. I know you can't read this, so I'm just going to briefly cover it. These are the things that he was able to train this robot to do, primarily through voice inputs and convincing it to use the arm and gripper assemblies to perform functions. Sorting and stacking dishes. This was placing a soda can and napkin into a recycling bin, followed by stacking a plate, bowl, and mug onto a tray. Egg picking. Corbot was trained to delicately grasp an egg, lift it from its container, and place it into a bowl. It did not break any eggs. Grocery boxing. Identify and grasp various items and place them into a box or bag. It was able to successfully do this with 4 items of different sizes and shapes, and was able to differentiate whether the items it was told to get were even in its field of view or not, and hence don't try to move it because it's not there. Cup repositioning, grip a cup, turn it upside down, turn it right side up again, and put it back down. Do it with various positions and various sizes of cups. Drawer and pillbox manipulation. Color cup repositioning. I'm not going to read through any more of those details. Frankly, with my little bit of manipulation of machine learning, for purposes of simply trying to find an orange cone. I am really impressed with this thing. This guy did this. Again, grade 9. Usually with my experience with a lot of these kids is that somewhere in the background there's a mentor. But that's one of the things that we've always changed or trained our science fair judges in is, not only do you have to have the right approach towards young kids when you're judging complex projects, but you also need to understand the fundamental element of, first of all, whose project is this really? Does the kid really understand what he did? And second of all, has he given credit where credit is due? When he had a mentor, where's the involvement of the mentor? What did they contribute? What did the student get out of it? Mentors are okay. They are fabulous. But you need to recognize what their input was and how well the student learned from it and extended what they learned from a mentor. That's just part of the process of running science fairs. Anyways, very, very impressive stuff, I thought. Now, in case you want to learn more about these two projects, these two robots and a lot of others, the Canada-wide Science Fair and the International Science and Engineering Fair, which is predominantly in the US, and a lot of others, use an online site called Project Board. And you can go to Project Board and select an appropriate science fair, in this case, the Canada-wide Science Fair, and in there you will find incredibly detailed information describing all of the science projects that were at the Canada-wide Science Fair. There were about 340 of them, incidentally, from all across Canada, including those two robots that I've just described to you. They're written up in incredibly good detail online on this site, and you can find that quite easily, and it's all public domain stuff now. Anyways, I admit I tend to think science fairs are a pretty good thing, but I thought you'd appreciate seeing these robots. They're very, very impressive examples of what, in this case, young kids, young scientists are capable of doing these days. I was impressed. Any questions?
Yeah, Tom, I've got a question.
Yeah.
And this is probably open to everybody, is how do we get younger students involved in STEM, interested and involved?
Yes. I did this same presentation to the Vancouver group on Sunday afternoon. And an interesting coincidence, one of the members of the Vancouver group is someone who runs a venture capital funding business, a fairly good sized one in Canada. Actually, he runs it throughout the world. And his group focuses on major investments in STEM related technologies and businesses. And he asked exactly the same question. Because there aren't enough people doing the kind of stuff that his group of 30 investors wants to put money into. Yeah. So it's quite something. He's going to he and I had an offline conversation. So he's going to spend some time getting to know the science fair organizations at various levels, because he thinks that there may be some longer range potential synergies between science fair groups and his group. So we'll see.
Good.
I found the same thing when I've been involved in running the regional fair here for a long time, and we have very, very good relationships with the universities and colleges in this area. And I was the judge in chief for quite a number of years, which meant I had built this enormous database of scientists and researchers and professors, several hundreds of them. And I became good friends with them. And I have had professors at the university who run research labs come to me and say, how do I get these kids to come to my lab? These professors make it a point, many of them make it a point that any of the postgrads and postdocs who want to work in their labs must volunteer at our science fair. He says they get stuck in a rut working just in their own lab on their own project. He says they don't get out enough and think about what's happening out of the box. And when you talk to a really, really smart 12 or 13 or 14-year-old, that kid is out of the box, let me tell you.
Sure. That's really good stuff.
Are are those two presentations that you shared, the humanoid robot and the turtle robot, are they online anywhere, Tom?
Yes. You see this screen I'm showing now?
Yep.
Yep. Well, go to Project Board, select the Canada-wide Science Fair.
Could you put the link in the?
I will. I'll do that in just a few minutes. It'll take me a minute to go back to it and get it. I will put in the links to their actual projects, and then from there.
That'd be awesome, because I thought some of the I'm just curious about some of the things that the kid who did the humanoid robot. It's like, models that or packages that I've never heard of, but that you sort of feel like, well, I ought to know something about that. At least, know what the name means, perhaps.
Well, with all the years of being the chief judge and having to, and also being the safety officer, so I had to run the ethics review board for human related experiments and vertebrate animal related and potentially dangerous physical stuff. Of course, you very rapidly learn how to leverage the really highly skilled people around you to help you with that. But part of what I had to do was learn a whole lot about a whole lot of different sciences. For instance, last year I was asked to consult on a fusion reactor, because one kid built a fusion reactor, a real one, on his dining room table. And I'm no longer the judge in chief. I don't have an active role in the science fair and haven't for several years. But the guy who's currently the judge in chief called me up and he says, help. He says, I don't know what to do with this. All kinds, nuclear physics stuff, complex laser beam stuff. My first exposure to machine learning and to artificial intelligence data analysis was through projects that appeared in the science fair that I had to learn enough, first of all, so I could understand it, and second of all, so I could assign valid judges to it, judges who would understand it. Yeah, it's I've learned a huge amount from that exposure. And of course, from a professional point of view, the networking is just unbelievable. But that's just me. But yeah, I will put those links in.
Oh, Kareem just posted the sea turtle link. That's cool. Thank you, Kareem.
Okay, he's got them. Good. So that's one, and the other one will be in there as well. And not only that, there's 340 projects in there just from this year. And you can look at multiple years of history of projects in there. And there are a lot of really good projects, and a lot of them are robotics based. First time I ran across CubeSat projects to go into outer space was through our science fair.
Wow.
Yeah, for those who are inclined to be dilettantes in a very wide range of sciences and engineering, science fairs are a fabulous experience. You learn a lot about a lot of things. So
Neat. Love that.
okay, so it sounds like one link is in. I haven't looked to see.
Oh,
Yeah.
Mark put one.
Okay, so there's the sea turtle. Okay, we don't have the other one yet. Is anybody looking for it, or should I look for it? This is called, let's see, what did he call his project?
Mark's looking for it.
Oh, wait, there it is right there. Carebotics, Carebotix. And I'm not sure where his project title is. I may not have it there. Let's go see. Okay, and
Link is posted.
oh, for the other one? All right, thanks. You're faster. If there's no other questions, I'll stop sharing my big picture here. Get this out of the way.
Very cool.
And there, we're back in the meeting. Yeah. Anyway, I admit this has been my community volunteering passion, as well as a nice professional adjunct for a long, long time. Is science fairs. Oh, and I like FIRST Robotics too. but it tends to be significantly narrower and deeper in terms of STEM technology encouragement, and to be blunt, very expensive. So there are. I went and looked earlier today. Within the accumulation region of the regional science fair here in Hamilton, which is very large. It's one of the largest ones in Canada because we've been asked to take over smaller science fairs because science fairs are very hard to run on a volunteer basis. So we actually involve about 9 school boards and about another 60 or 70 private schools, independent schools within our boundary areas of our regional fair. And within that area, there are only about 12 or 13 FIRST Robotics groups. They're all very good. Most of them have been around for a while. But there's only about 12 or 13 of them within that same boundary area where we routinely draw 400 or 500 kids and 400 science fair projects across a very broad spectrum of STEM activities.
Wow. Cool.
Yeah, it's fun. But I do robotics now or model airplanes.
Thanks, Tom.
Well, I hope that was useful.
Robots are pretty fun, I gotta say.
I agree. So. But I'll tell you what, I went into the science fair process as a judge and as a parent, because both of my kids got involved as well. Thinking, I'm a pretty good engineer and I know computers and I know electrical stuff. What else is there to know? Oh my God. Then I became judge in chief and I was the general chair for a few years and everything else. Boy, oh boy. Then I find out there's when you accept projects that involve human research, and that's very common because every kid in school that has a health class does human research. And most of them don't do it exactly by the books. And you have to take a lot of time explaining to kids that when you do formal human research, there are now ethical issues and due diligence issues and approval issues and a whole lot of things that you simply can't do, at least not, and bring them to our science fair. Then the vertebrate animal stuff. Yes, I learned a whole lot of stuff quick and was fortunate to have a network.
Good on you, Tom. Good on you for like volunteering in such a worthy pursuit.
Thank you. It was fun and enjoyable, and a huge amount of benefit comes out of it. Because we have to raise all our own funds, I got involved in fundraising, and after doing some discussions with sponsors and potential sponsors, some of them said, what's the point? Why are you doing all this? So then we started to look at what happens to science fair kids after they go on past the science fair. In other words, what do our alumni get involved in? And we started to do some research on what's the alumni up to. And I got blown away. These people who do well or reasonably well at the science fair level, some of them go on and become literally world-class researchers, engineers, business people, you name it, world-class. You see them talking in TED Talks all the time. Yeah, they're pretty capable. You see them running significant sized businesses. So yeah, it's a fun thing, a very reassuring thing to have done that and then feed that back, not only to our sponsors, but back to the school boards and the schools that we encourage to come into the science fair. And all of a sudden I got a teacher who says, oh my God, I want my class to enter. Those are the better teachers, of course, but those are the ones you go for, is the better teachers.
All right. Anyone else got anything before we throw it open to open mic?
Yeah, I was gonna say if you could get CareBot to master, like adult diaper changes and cleanup, he'd be, the richest man in the world, I think, because it's not a task anybody wants to do.
The true personal care worker.
That's right.
All
At
right.
least that was.
Open mic. This found interesting stuff.
I've got something I'd like to share, Paul.
David.
So, as some of you also are, I'm a member of the Dallas Makerspace, and I check in on the talk channel every once in a while. And one of the topics they brought up was this 10 to 15 year DMS members. They're going to have an anniversary party acknowledging them, which I thought was kind of interesting, but I scrolled down through it and found this more interesting. So I guess back in 2010, they had some people that donated $100 each. And I got to looking through some of these names and I thought, hey, I think I recognize some of these names.
Yep. I think a good half, I guess a good half of them were members of the DPRG at one point or another.
Yeah. I see Paul's name in on there.
Kareem.
Yep.
Parody is Doug's son.
Okay, I was wondering what the relationship was there. Yeah.
Yep. And Kareem and Mark Havens was in the DPRG. So was Jason. Jason Henderson.
So was Steve Rainwater.
Yep.
Yeah.
Gus,
Eagle.
Gus was too. And, but you know what? There is a page on the website in the historic tab that's called The Founding of DMS. And it's interesting reading. Some of it was put together. Some of it is a screen capture of web pages at that time, but the other is explanation of the events by Steve Rainwater. So if you ever just want to know about the DMS and DPRG, that's a good, DPRG basically founded DMS. And so it was kind of cool.
Yeah, the guys who did that really had a vision.
Yeah.
They understood that there was a need for something like DMS, but that it was going to be a very different thing than the DPRG, with a different financial model and different benefits, and the two organizations have gone on in parallel, and DMS has grown like crazy.
Yeah.
Mm-hmm.
Yeah. Pretty neat to see.
Yep. Just wanted to share that and say thank you to the people on here.
Yeah.
Yeah.
Cool.
So
I'd
is
rather
the
get a
DMS
founding
still one of the
members
largest?
discount, honestly. They upped the rates to $50 a month for and I know that's already low for many people, but that's like a legacy rate. And yeah, it's like I get up there maybe twice a year, and that's almost always on DPRG business, not DMS. So it's like I'm struggling to keep my hat in the ring.
Yeah. Well, I'm actually planning to use the Makerspace a little more this year. I'm working with my daughter on some projects, and the tools that are at the Makerspace are so good that it's kind of hard to beat some of them.
Yeah, that's true.
Yeah.
Well, I use their wood shop to make my platform for my robot. So
Yeah. DMS is a wonderful asset. I mean, I think. I don't know.
Oh,
There might be.
it
There
absolutely
might be.
is. I would,
Yeah.
I would be happy to, sort of help kick off something like that all over again. It's just, I've moved further away and
Yeah.
I'd get no use out of it. But,
Well, that's the same thing here with me. If I weren't getting a legacy rate, I probably couldn't maintain it because, maybe now, but in the past, there's been years that I've never even gone there once.
Yep.
And except for the DPRG. And the reason for it is when it was, I guess I took a slightly different route. I have them, and I know you did, Kareem, too. I mean, you've got 3D printers, you've got CNC machines, you got wood, kind of a wood workshop. I mean,
I don't need it as much as a lot of people.
I need it there's so many incredible different tools down there. When I say that, so like, let's say you got a table saw, they got a table saw.
They got a cabinet saw.
Yeah, I mean,
exactly.
if you got a hobby lathe, they got an industrial lathe. I mean, you got a shoreline mill, they've got a Bridgeport. You know what I mean? It's just like, whoa.
That's true.
What about the CNC plasma cutter that Mark cut out Roby's new knees on?
I was going to say, we have a Shoreline and a Bridgeport, so.
Yeah. Yeah. Do they have that, Mark?
And the Haas.
Yeah, and if you finally decide you really, really want to get into it, they have the Haas, But it's kind of cool. I have to admit that. But the problem is, like right now, I'm in and out on this meeting because I'm trying to 3D print some stuff in parallel, and so for 3D printing, I would not go down to the Makerspace 4 anymore. Laser cutting. I did some work with Mark, and boy, that was so trouble free. That was really, really nice compared to my little machine. So I don't know.
I would say that the first laser cutter was the thing that really cemented the Makerspace continuity. It was like that was the tool that everybody wanted in on. Before once we had our very first space.
Yeah, that was with Elisa Pipes.
Yep.
And I understand Mark actually owns that machine now.
Oh, really?
Yeah, it's a K40. Huh. It's a K40. And
original Dance Makerspace laser. Yeah. I got it at home.
Yeah. And I mean, we used the shit out of that thing. I mean, it was.
That's true. Yeah.
Yeah.
And so that's a little old Dance Makerspace words on the side too. I kept them on there.
Yeah. But Elisa put one of the things she did, because the K40 by original design didn't have it. She put a stage that would go up and down, so you could adjust like the ones like the good lasers that are at the DMS now. You could adjust to get your focus just right, and that was really made that little K40 flexible. I don't know. Did that survive? Can you adjust the bed height?
Yeah, it's manual. There's a screw.
Yeah. It used to be on the bottom. That's
what I on the bottom. Yeah. I'm trying to think. It's been a minute since I've looked at the laser. I'm still getting it working. So. Yeah.
Doug, did you ever fix your laser?
No, well, like I said, I went down and did it at the DMS with Mark's help, and but the more I'm thinking about it, I just haven't. I'm doing so many things right now that once I found a solution to the problem, it kind of like dropped to the bottom of the list, and I'm working my way back up. And I think that was part of my problem was kind of a stupid. I think I started experimenting with different focus lens. So I had the standard 2-inch focus lens, and I had a 2.5 inch, and I think I even had a 3. And so I think I had a 2.5 inch lens in there, and I was focusing it for a 2-inch, and you know what? It didn't work real well. I mean, the thing is, it would cut, but it just didn't have no power. So I'm thinking that it could be that the problem could be that simple, or it could have been in the beginning that simple. After it didn't work, you know, I went and tried to do mirror adjustments and all of that crap. And so I don't know if I got that back into the stock hardware on K40 is it's cheap. But anyway, it's good enough. You don't need any more, but it's it can't, once if you screw with them, if you screw with the mirrors, which you usually shouldn't have to do unless you move the tube, you know, you set them, it's a pain to set them. To get them really right, you can get them close real easy, but getting them really right takes a little bit of work. Yeah. But the K40 is still an excellent buy for somebody who's just starting out. If I were given, you know, if somebody said, Doug, do you want a laser diode or do you want a CO2 laser? I'd still go with the CO2 laser. It's just much more flexible. Yeah.
Yeah, well, I've been using PLA for years, well, for a long time, and I got some PET-G, but I haven't used PET-G in a couple of years. But for my Robo Columbus robot, I don't think I should use PLA because it'll probably melt in the sun. So
you could get away with it probably, Mike, as long as you weren't using it for motor supports and crap like that. Because we're in November. But
yeah.
You know, if you had it in your car for any time.
Right. In the back of the car, you pull it out and then everything's all out of whack.
Yeah, out of whack. And believe me, it doesn't take that much.
That was funny, that post that Kyle put up of how his robot sagged in the car.
Yeah.
Right.
That's classic PLA. Yeah, I've got a bumper. I think I took it down to the makerspace, and the bumper on it was a prototype bumper, and it just, you know, it looked like somebody chewed on it. So
yeah.
Well, you know, I was looking at that stuff that Mike introduced earlier, the cone slayer, and apparently that model is now part of Lunux, LUONIS or IX, the people that make Oak Delight and all of those.
Right.
It's actually in their their Zoo Master.
Right. There's
so
Zoo models. Yeah.
Zoo model.
Models.
I wasn't able to actually find the cone data set, but they explain how they did it. Essentially, they used a video capture. They captured a video of them riding around on a course that was lined with cones, and then extracted images from it. There's, you know, from what I've read about model selection, that's not really the best way to do it. And they ran into some of those issues in that if the cones were exactly like the cones that they were trying to find, they could find them. But anything that was a little different, they couldn't find it. You know, don't say they didn't find them, but their performance degraded.
Right.
So there's some other things going, but it definitely worth looking at.
Yeah, and they also they recognized that and then added more cone models into it, and then realized they needed to have anti-cone models.
Yeah.
And so they worked on it they go, oh, this isn't working good. And was modifying it and fixing it.
Yeah. Well, I mean, it was a great effort. I mean, that's,
Yeah.
I'm not trying to,
Oh, yeah.
there's another guy who out there who did something similar when I first was looking at this, and he had a little rover robot just like we make, and he drove it around in a parking lot and was capturing images, and he's on the web too. I don't know his link, unfortunately, but if you looked at cone detecting traffic cones, I think you would find them. And the nice thing about his is he had some of his scripts where you could use them for your own data capture. It's kind of cool.
Yeah, so I'm curious if that cone slayer, since it's built on cars and streets, if it's going to work well with trees and bushes.
Yes. Well, yeah. That's you know what, at least his initial thing when he was driving around the cones, that reminded me of a lot of like donkey car. You know, when you set up a course of a donkey car course in a room, the donkey car doesn't just memorize the course that you drive it on. It memorizes the background, it memorizes the people sitting in chairs, it memorizes everything, and that's all incorporated into the model. It's kind of interesting. It makes it stronger, but that's one. If you guys really, if we want to try some new a new old contest, we have rules for a donkey car contest, and it would be fun to run again. Unfortunately, when we had somebody who really aced it, I guess I got excited and forgot to capture the video. So the guy did a fantastic job, and I captured the video. And then, but by that time I realized that, hey, I didn't capture the video. So I got his second run, but in his second run, he had tweaked it to go faster. And so it was still very impressive, but it's not as impressive as the first one. We actually ran it through, the course actually ran through the 6-can arena, so you had to get through the 30-inch or 31-inch gate on both sides of the arena as part of the course. It was kind of fun. So.
Has anybody been down to Micro Center lately?
A couple of weeks ago.
Yeah, they've made a lot of changes in the DIY area. Now it looks like it's mostly 3D printing, supplies, filaments, and.
Oh yeah, they did move them into there.
Yeah.
They still have their wall of Adafruit and stuff like that. So
Smartphone and Inland. Yeah. But not nearly as much, I guess other stuff that they used to have on the other racks. It's all filament now.
Yeah. Well, hey, that's where I buy my filament.
Yeah. Yeah. Well, I was thinking they probably make a whole lot more on a 3D printer than they do on a little Adafruit board, so. Oh,
for sure. Yeah. I've often wondered how they managed to justify that. I mean, I'm sure part of it was that they're, tanners dying and fries going away. I mean, they kind of like had the whole market for themselves, and they're right across from TI. So all the TI nerds go there. That's where they do their lunch break. So
captive market.
Yeah.
So yeah, that was a little surprising. It's like, But.
Yeah. So yeah.
Yeah. Well, I was noticing that their filament selection wasn't that unique and large. But I mean, they had a whole bunch of filament, but not a bunch of different types. I mean, they had 4, 5, 6 different types.
But when I was in there a couple of weeks, Mike, I since I use ASA, I was looking for that, and they did not have much. And what they had was one of my biggest complaint. Well, not my complaint, but one of my concerns was you could only get ASA in what I'd call man colors. Like brown, dark hunter green. Gray. Those.
Nope.
I mean, they're great they really look really good on robots. Okay, but now when I went in here this time,
You needed pink, right?
Yeah, well, when I went in here this time, it was, pepper, what do they call it? Stripes and pink and, bright colors that, I wouldn't dare put on my robot. I'd be embarrassed. So I don't know.
I'll give you robot some color, Doug.
Yeah. Yeah. The thing that one of the things, and I think they have it in the back and they don't tell you about it, was I couldn't find any black and white, but I found a roll of black ABS and it was called Galaxy Black. And I thought, oh, that sounds black. So I took it home. Well, it's sprinkled with little bits of, what do you call it?
Does it glitter?
Glitter. It's got glitter in it or something. So, it's got these little pieces in it. And I was looking at that and I said, well, it's not really black. Since I was trying to print piano keys, it was, it was not, well, it was a little interesting. It worked, but it was a little interesting.
When I bought my 3D printer kit years and years ago, the mail order company I bought it from had a special deal on filament. I knew I need some filament, so really low prices, and you could put up to 4 rolls in the package with no extra shipping.
Yeah.
So, and they got all kinds of colors. So I thought, this is great. So I was going to order 4 rolls of filament, but at the time I did my order, all they had left was blue and pink. So I printed a lot of pink stuff for years.
Yeah. Well, I've got a roll of pink too, because I'm making parts for my daughter's stuff, and she uses a lot of pink and blue. So, she would be perfectly happy with that, Tom.
This is
Yeah.
robot carcass.
Mike's not embarrassed.
It's last year's robot carcass.
Yeah.
I need to pick it apart and take the screws out and throw the plastic away.
Well, there are certain classes of family influencers who appreciate the pink, so it's to keep them happy.
So, I hear something in the other room. Gotta go.
So if just so changing subjects, I posted. I don't know if any of you follow Benji Holson. He was a project manager, I guess, at a place called General Robots, I believe, attempting to build robots to do a wide variety of things on homes and businesses. And anyway, they shut down, but he writes blogs every now and then. He's probably written a dozen by now. And he really bears the scars of being a leader in building robots and all the things that can go wrong, particularly from the software point of view. I think he must have been a software manager. Anyway, I posted in a link to his latest blog post on the Discord in the general channel, and it's very funny, very very true, very tongue in cheek, very dry about the evolution of AI and convergence with robots, and every now and then the next greatest thing comes along, like expert systems, and everyone thinks AI is done and celebrates, and then after that comes a winter of discontent because it doesn't work as well as it was promised. Anyway, it's a good read if you have a bit of time. It's quite funny.
All right. Well, I'm going to take off. So maybe I'll make it Sunday.
All right.
All right.
Paul, you heading off to sunnier climes right now?
No, I just checked the mail and there is no Ross interest group tonight. So,
Oh.
so I'm not going to.
Wassalam.
Sorry, you stuck with me for a bit. But it sounds like, I don't know, England's got anything else? It sounds like we might be losing energy here. If you don't,
Yeah, it was the I'm not certain what it was at the time. I printed it at the makerspace, and I don't know if it was free filament or just labeled as free because nobody wanted it. But the encoder housings, show you the pink underbelly of my robot there. The little encoder housings were from, the filament no one wanted, so happened to be pink.
Well, I've only used PLA. I was following some of the discussion of filaments on the DPRG Discord stuff earlier, and I only use PLA, but and I have had that very same experience of printing marvelous PLA stuff to use in the car in the summer and having it droop. So I've done that, learned that one the hard way. But I also found that with the assistance of my wife, the artist, you can paint PLA extremely well with external acrylic paints. And that makes it very, very robust. I printed a fancy doorknob for the little free library we have outside at the end of our driveway. And I printed it, 8 or 9 years ago out of PLA. And my wife painted it up to look really, really fancy. It looks like an ice cream cone, actually. And it looks every bit as good now as it did when I first put it out there. So painting with external acrylic paint really, really seals up the PLA really well in terms of the impact of UV. So very impressive.
I mean, isn't like the melting point of PLA like 200 degrees?
It unfortunately, it covers a very broad range. So it's not 200, below 200, it's fine. Above 200, it melts. It's not the way it works. It starts to go soft at around 130, 120, 130 degrees Fahrenheit. And
Wow.
you can easily get that in a car in the summer.
Yeah.
So that's the problem, is it starts to go soft.
Even in Canada.
Even in Canada. Yes.
I was waiting for someone to say that.
I was kind of curious about the research that you were talking about with the Canadian Navy. Are they concerned about the Arctic Passage opening up and guarding it, or?
Well, Ray, it's a messy, complicated pile of politics. And down underneath it is the issue of, who's going to get aggressive in the Northwest Passage first, the Russians or the Chinese, right? And since the Canadian military has basically ignored the whole thing for 150 years, they figured they better start doing something. So they're looking at developing permanent bases both on land and serious year-long presence at sea. All the way through. The Northwest Passage is open all year. Like, you can go all the way through there all year now. And there are ships that have done it already, although it's not considered an excellent path yet. But there are ships who are doing it now. There are cruise ships that go all the way through there now full of passengers.
Wow.
which has the indigenous folk who mostly live up there very concerned because they're worried about pollution and environmental impact. That's very important to them. It's the Wild West. I mean, nobody looks after it. Hence
Yep.
the patrol vessels.
Yep. Well, plus you may have a hostile neighbor to the south too, America. That
You never know.
may need to protect yourselves against. So
I have a friend of mine in the military, in the Canadian military, who's just recently retired, and he has spent a lot of time working with the auxiliary military forces, which is comprised of indigenous folk who live in the far north, but who are seconded basically as reserves with the military. And that's the dominant activity, the dominant force up there. And he would go up there for 6 or 8 weeks at a time to basically to get to know them and to provide training for them in various forms, various things. Fascinating. He's also an extremely good amateur photographer. So it gave him a wealth of opportunity to take pictures nobody else could take. It was very interesting to hear him talk about his experiences with the auxiliary forces across the north. There isn't a whole lot of military presence up there at all. That's probably going to change, and who knows how fast. Our federal government says a lot of things.
You're giving away all our secrets, Tom.
Oh yeah, sorry, Pat.
We have a lot of friends in the South, and we're not holding anything against them because of political systems the way they are and political views. We still have friends down south.
Yes, you do.
Yep, and it's the reality that there are silly people living in Canada too, from a political point of view, no question.
Oh yeah.
What you got to do is watch what they're doing up here.
Okay, well, this is not a political forum, so let's
Right.
come back to robot. Does anyone have anything else robot news? If not, we might call it. Sounds like it's time. All right. Good talking to you all. See you all
Good night.
next week.
See you next week.
Hey.
Night.